Hi students. So till now we have studied three problems on continuity chapter which are very important for your annual exam. So now let us go for the fourth problem which is important for your annual exam. So in this particular question, that is, find the values of a and b such that the function defined by f of x equal to 5 if x is lesser than or equal to 2, ax plus b if x is in between 2 and 10, 21 if x is greater than or equal to 10. Clear? So here the function is given as continuous. Clear? Function is given as continuous, and what they are asking, find the values of a and b. That means they are asking the values of a and b whenever the given function is continuous. So let us try this. Here there are 2 points. One is 2, another one is 10. That means you have to check continuity for 2 points. One is for 2, another one is for 10. But they have given this is continuous function. That means it is continuous at 2 also and it is continuous at 10 also. Clear students? So for that reason we have to use the condition of continuity, that is limit extending to a f of x is equal to f of a. So we have 2 points at x equal to 2, at x equal to 2 and at x equal to 10. You have to solve at both the points to find the values of a and b. Let us take at x equal to 2. See here, at x equal to 2 your answer is 5. So that means f of 2 equal to 5. Clear? Come to the next one. X is greater than 2. X is greater than 2 means it is the right hand limit of particular function. The right hand limit of extending to 2. So here it is given that x is greater than 2. So we have to take the right hand limit of 2. Therefore that is RHL limit extending to 2 plus, what is your f of x? At RHL your f of x is ax plus b. So write ax plus b. X is going to what? 2. So that is 2a plus b. Therefore at x equal to 2 your given function is continuous. F of 2 will be 5. RHL will be 2a plus b. Clear? So now if I use the continuity definition, we can write it as 2a plus b equal to 5. So you take this particular equation as 1. That means 2a plus b equal to 5 is your equation 1. Now let us go for at x equal to 10. At x equal to 10, see, f of 10 is 21 because equal 10. That means your value is 21. Now let us go for RHL. Sorry, x is lesser than 10 means it is left hand limit RHL. That is limit extending to 10 minus, because we are finding the left hand side of 10. 10 minus again ax plus b. Therefore this will be what? This equals x value is 10, a plus b. Again it is given that it is continuous at the point of 10. So if it is continuous at the point of 10, your equation will be 10a plus b equal to what? 21. So this is your second equation. Have you got the point, students? So that is, first equation is 2a plus b equal to 5. Second equation is 10a plus b equal to 21. So you have to solve this both the equations to find the values of a and b. So for that reason, let us find the values of a and b by solving these two equations. That is 2a plus b equal to 5. Next one is 10a plus b equal to 21. If I subtract these two, that means it will be what? Minus 8a. This will be equal to minus 16. That means a will be equal to 2. Clear, students? If I simplify these two, I am subtracting 2a plus b equal to 5 from, I am subtracting 2a plus b equal to 5 and 10a plus b equal to 21. 2 minus 10 minus 8. This will be cancelled. 5 minus 21 will be minus 16. So a will be equal to 2. If a is 2, put here a equal to 2. 2 into 2, 4. So b equal to, it will be 1. Therefore, if I put a value here, the b value will be equal to 1. Clear, students? So put a equal to 2 in this first equation. 2 into 2 equal to 4. So if you bring 4 on this side, 5 minus 4 will be equal to 1. So that will be b equal to 1 and a equal to 2. So this problem is important. Clear, students? These are the exercise problems of your continuity and differentiability, and very interesting problems and important problems. So for that reason, a equal to 2, b equal to 1 will be the answers for your particular question. Clear, students? Okay, students. Now let us go for fifth question, which is important. Clear? So here, find the value of k so that the function f is continuous at indicated point. Here the function is continuous at x equal to pi, and you have to find the value of k which is given in function. As you all know, if the function is continuous, limit extending to a, f of x is equal to f of a. So by using that, we can solve this problem very easily. So if this is continuous at which point? X equal to pi. So what is f of pi? Let us find first. What is f of pi? F of pi is at x equal to pi, kx plus 1 is your function. So that will be k into pi plus 1. So k pi plus 1 is your answer for at x equal to pi. So using that, now let us go for the greater values, that is x is greater than pi. That means RHL. So by using RHL, limit extending to pi plus, what is your f of x? Your f of x is cos x. Cos x. So this will be equal to what? Cos pi. So cos pi value is minus 1. Cos pi value is minus 1. So from the continuity of the function, we know that limit extending to a, f of x, or limit extending to a plus f of x is equal to f of a. That means RHL is equal to f of a, LHL is equal to f of a. So in our problem, we have RHL. That means, we have, right hand limit. So using RHL, we can write it as cos pi. That means minus 1 is equal to f of a is k pi plus 1. K pi plus 1. So if I simplify this, it will be k equal to minus 2 by pi. K will be equal to minus 2 by pi. Very simple problem. Clear, students? So I think you got my point of solving the value of k in this particular question. Okay, students. Now let us go for the sixth problem. Again, as same as previous problem, that is, find the value of k so that the function f is continuous at x equal to 2 for f of x equal to kx square if x is lesser than or equal to 2, 3 if x is greater than 2. So let us use again the same definition of the continuity, limit extending to a f of x equal to f of a. For using that, again here see, at x equal to 2 your function is kx square. That means at x equal to 2 your function will be f of 2 will be kx square. That means x value is how much? 2. K2 square equal to 4k. Your value will be 4k at x equal to 2. Now let us go for RHL. Therefore your right hand limit is equal to what? 3. They have only given that at x is greater than 2 your value is 3. So that means 4k equal to 3. Therefore k equal to 3 by 4. So this will be very easy problem comparing to other problems. Therefore k equal to 3 by 4 is your answer. Okay, so now let us find the value of k for the 7th question, so that the function f of x equal to 1 minus cos 2x divided by 1 minus cos x, if x is not equal to 0, k if x equal to 0 is continuous function. Okay students, so to solve this you must remember the formulas of trigonometry. Clear? You try to remember the formulas of trigonometry. They are 1 minus cos 2x equal to 2 sin square x. Clear students? 1 minus cos 2x equal to 2 sin square x, and for this you must remember 2 sin square x by 2. Clear students? So you remember those formulas. If you remember those formulas, these particular problems are going to be very easy. If you remember those formulas, the problems are going to be very easy. So now at x equal to 0, that means f of 0 equal to k. See here, it is given. At x equal to 0, it is k. Now let us find limit extending to 0. Here we are not going to use LHL and RHL because the terms are given as equal. The terms are given as equal. So for that reason we are not going to use LHL and RHL. Limit extending to 0. What is your f of x? 1 minus cos 2x divided by 1 minus cos x. So this is your problem. So now this is equal to what? Limit extending to 0. 1 minus cos 2x is 2 sin square x divided by 1 minus cos x is 2 sin square x by 2. Clear students? So by using these two terms, now let us simplify the value of k. So see here, x is tending to 0, cancel 2 and 2, no problem. Sin square x divided by sin square x by 2. So now I will adjust my terms. So sin square x divided by sin square x by 2. As you all know, sin square x can be written as sin square x divided by x square multiplied with x square. So this is first term. Next, I will adjust this with x square by 4 divided by sin square x by 2, that is multiplied with 1 divided by x square by 4. 1 divided by x square by 4. So now if you simplify this, here limit extending to 0, sin square x divided by x square will be one term. Second term will be x by 2 divided by sin x by 2 whole square. So this also can be written as whole square. Here you can write this term as 4 divided by x square, and this multiplied by x square you write as it is. Clear students? So sin x by x whole square, x by 2 divided by sin x by 2 whole square, 4 by x square into x square. So you know the formula, that is sin x by x is 1 x by 2 divided by sin x by 2 is also 1. Limit extending to 0. Here I can cancel x square and x square. If this is 1, this term is 1 into 4. So your answer will be 4. Your answer will be 4. As you all know, your f of 0 equal to 4. F of 0 equal to 4, and that is equal to your limit extending to a f of x. F of x. So that is f of 0 is what? At x equal to 0 it is k. F of 0 equal to, sorry, f of 0 is k. Limit extending to a f of x equal to 4. So this implies k equal to 4. Clear, students? So see this carefully. That is limit extending to a f of x equal to 4. F of 0 equal to k. From the definition of continuity, f of 0 equal to limit extending to a f of x. Hence k equal to 4 is your answer. Clear, students? So this is also very one of the important problems. That is f of 0 equal to limit extending to a f of x. From the definition of continuity of limits, we know that f of 0 equal to limit extending to a f of x. Here f of 0 is k. From the definition, f of 0 is k. Limit extending to a f of x equal to 4. Therefore k equal to 4 will be your answer from using the definition of continuity. By solving this, be careful. Adjusting x square terms, adjusting x square by 4 terms, multiplying x square, dividing x square, multiplying x square by 4, dividing by x square by 4. So I will take this as separate term, this term as separate term, take x square outside. So 4 by x square into x square will be get cancelled. So your answer will be 4. Therefore answer is k equal to 4. Okay, students. So now let us go for the 7th problem. Again, that is find the value of the k so that the function f of x so and so is continuous function. So for that reason, let us again solve the problem by same method. First we have to find f of 5 because it is continuous at 5. F of 5 equal to how much? F of 5 equal to kx plus 1. So that will be 5k plus 1 because x is equal to 5 for this particular function. Next, let us go for RHL because here x is greater than 5. Right hand limit. This implies limit extending to 5 plus f of x is 3x minus 5. X value is how much? 3. So 3 into 5 minus 5. So 15 minus 5 is how much? 10. So your answer will be 10 for RHL. F of 5 is 5k plus 1. For the continuity, we know that limit extending to a plus f of x equal to f of a. So that is 10 is equal to 5k plus 1. So therefore k equal to 9 by 5. If I simplify this, k will be equal to 9 by 5. So this is your answer for your 7th question. Okay, students. Now let us go for the 8th problem. That is, for what value of lambda is the function defined by f of x equal to, first one, see here, is continuous at x equal to 0. Second one is, what about at x equal to 1? So different problem, little bit different problem for previous problems. Clear, previous problems were directly given that they are continuous, find the value of k. So but here what they are doing, for what value of lambda the function defined by f of x equal to as like this is continuous at x equal to 0 they are asking. That means first thing is it continuous at x equal to 0? That you have to solve. Are you getting my point? That means if it is continuous at x equal to 0, then you can find the value of lambda. Are you getting my point? Again, at what about x equal to 1? Suppose if it is continuous at x equal to 1, then what are the values of lambda? Are you getting my point, students? So please remember here, directly they have not given the function is continuous. First they are asking, is it continuous or not? If it is continuous, then find the value of lambda. You have to understand the problem. Clear, my dear students? So in this particular question, what they have asked, that is very, very important. So please observe that carefully. Here they have not given the function is continuous directly. They are asking that is it continuous or not. If it is continuous, then what is the value of lambda? Again they have not given only 1 point. They have given 2 points. You have to check the continuity for 2 points. Clear? If they are continuous, you can find the lambda. If they are not continuous, then there is no need of lambda. You can say that lambda is not possible. Clear? Okay, let us solve now. At x equal to 0. At x equal to 0. First let us find f of 0. What is f of 0? Equal to 0. Function is lambda x square minus 2x. That is lambda x square minus 2x. Here x value is 0. Therefore x is 0, 0. Lambda into 0 minus 0 will be equal to 0. That means f of 0 is 0. Clear, students? So now let us find limit extending to a plus, that means 0 plus RHL of your 0, RHL of your 0, that is 4x minus 1, 4x minus 1. See, x is greater than 0 means RHL of your 0. Therefore 4x minus 1, 4 into 0 minus 1, so it will be equal to minus 1. Therefore f of 0 is not equal to your RHL, that is right hand limit. F of 0 is not equal to RHL. This implies lambda is not possible. Lambda is not possible. That means there is no value for lambda. Clear? Therefore, f of 0 is not equal to lambda. That implies lambda is not possible because it is not continuous. Here you can write because this is not continuous at x equal to 0. See, because not continuous at x equal to 0, f of 0 is not equal to RHL, implies lambda is not possible. Hence, at first question, it is not continuous at x equal to 0. Clear, students? So now you got the idea of the first question in this. Let us go for the second one. Second one is at x equal to 1. At x equal to 1 means, see this function. For this function only you have to find x is greater than 0 because 1 is greater than 0. This only you have to use. Clear? For x is greater than 0, this is possible because 1 is greater than 0. For x is greater than 0, we can take at x equal to 1 f of x minus 1. That is f of 1 equal to 4x minus 1. That is 4 minus 1 equal to 3. 4 minus 1 equal to 3. Again at RHL, that means right hand limit you can find because for x is greater than 0, or you can find limit extending to 1. Don't use RHL. You can use limit extending to 1. For limit extending to 1, again it is greater than 0. Again you have to use 4x minus 1. So 4x minus 1, this will be what? 4 into 1 minus 1, it will be 3. See, f of 1 equal to your limit extending to 1, 4x minus 1. Clear? That means f of a is equal to limit extending to a f of x. So if this is true, then what you can say? It is continuous. Say, that is, it is continuous. It is continuous at x equal to 1. It is continuous at x equal to 1. And now what about lambda? See, in this equation you don't have lambda. 4 1 minus 1 equal to 3. Here you have 3 equal to 3. Here you have no lambda. That means you should write every lambda of real number. That means for every lambda belongs to R. That is, for every lambda belongs to R means lambda is any real number. Please remember that lambda is any real number for your second question. Lambda is not possible for your first question because here it is not continuous, here it is continuous, but in your equation f of a equal to limit extending to a f of x, lambda is not present. That means in this particular equation the lambda is not present as it is present here. See, lambda 0 minus 0, here it was present, clear? But there is no lambda. That means you should write lambda belongs to any real number. For every lambda belongs to real number, that particular function is continuous. That means the second one is continuous, first one is not continuous. Very, very tricky problem. Please practice this more and more because this is not as same as your previous problems. Again I am repeating, this is not same as your previous problems. It is little bit different problem. So for that reason you have to practice it little bit more, and it is very tricky. They are asking 2 points. Are they continuous or not? If they are continuous, then what is lambda they are asking? For that reason, first one there is no lambda. Second one, lambda belongs to every real number. Clear? Okay. Okay students, now let us go for the 9th problem, that is find all the points of discontinuity of f defined by f of x equal to mod x minus mod of x plus 1. That means here you have to find the points of discontinuity. Clear students? If you want to find the points of discontinuity, again you have to see that it is continuous or not. So for that reason, see here, we know that mod x is continuous. Mod x is continuous function. Mod x is continuous function. Next, mod of x plus 1 is again continuous function. Continuous function. These all are from the results. Clear? We know that this is continuous. Then mod x minus of mod x plus 1 is also continuous. Is also continuous from the difference of continuous function is continuous. That means mod x is continuous function, mod of x plus 1 is continuous function, then mod of x minus mod of x plus 1 is also continuous from, see this, from the difference of continuous function is again a continuous function. This is theorem. Clear? The difference of continuous function is again a continuous function. It is sufficient if you write this much in your exam. There is no need to prove the theorem. Clear? If they ask this problem, there is no need to prove the theorem. You just write the difference of the continuous function is continuous function. Hence, mod x minus mod of x plus 1 is also continuous. Therefore, given f of x is continuous, hence no points of discontinuity. No points of discontinuity. Clear? Hence, there are no points of discontinuity for this particular function because mod x is continuous, mod of x plus 1 is continuous. We also know that the difference of continuous function is continuous. Hence, the given function is continuous. Therefore, the points are not having discontinuity points. Clear? Therefore, the function is not having discontinuity points. Please remember that the difference of continuous function is also continuous. That thing you have to write in your exam. You should write this is continuous, then difference of these two is also continuous. With that you write this result. Clear? Hence there are no points of discontinuity. Therefore these are the 9 problems. Clear, students? So in previous class I have solved some problems. That all problems are going to be revised in coming length of the video. That means already I have done in previous class that which are 4-star problems. That means which are important for your exercise. So for those problems I am just going through the revision. In this video you just go through those all terms. Clear? Okay.